So far, we have learned how to apply a law of conservation of momentum for a head-on collision. Now let's look at one different kind of collision when it happens at an angle, and then how to use this law to answer or solve these kinds of questions. Okay. So ball of mass 0.25 kilogram, which is 1/4 kilogram, moving on a horizontal floor, collides with a vertical wall as shown in the figure. The speed of the ball before and after the collision is 4 meter per second. Okay, so before it collides, basically speed is 4 meter per second, and after also it is speed is 4 meter per second. But remember, because the velocity is a vector, momentum is a vector, the direction has changed. Okay, so that's the key. So calculate the magnitude and direction of momentum change of the ball. Okay, so all we need to do is basically calculate the change in momentum, right? And as the ball will actually collide with the wall, basically force will be exerted by the wall, and that is going to change the momentum, right? So force is required to change the momentum. In this case, the force is going to be downward, right? Changing the momentum. So we expect the change of the momentum towards down, right? But let's look at how the initial momentum is, okay? So for that, we are simply going to say the ball was moving like this, okay, with a velocity 4 meter per second, okay, and this angle which is given here is 45 degrees. So this is 45. This is also going to be 45. Okay. So what is the initial momentum in the vertical direction? This is going to be my momentum in the vertical direction, in the y direction now. Is going to be m, which is 0.25 into 4 into the component, right? So the cos 45, right? So mv cos theta. Okay. You get that? So in this direction, the momentum is going to be like that, and that is upwards, right? So we're going to take the upward direction as positive. So this will be a positive number. So 0.25 divided by 4. This is going to be simply cos 45 degrees. Okay. So that's very easy in the positive direction. Okay. After, when the ball returns, basically it is velocity changed in this direction, and again this angle is 45, so this angle is also going to be 45 degrees, right? So what is the momentum in the y direction? The y direction momentum here now will be downward, right? So this is our initial, we can say. So final is downward this time, so this is going to come with a negative sign. Again, the v is 4 meter per second, so mass is going to be 0.25, right, into 4 into, again, cos 45, right, cos 45. But this time, this is going to come with a minus sign, so my p final is again going to be minus cos 45 degrees. Okay, fine. So how much is the net change? That is what it is asking. How much is the net change? The change in momentum is going to be p final minus p initial. Okay, so p final is minus cos 45 and then minus cos 45. Can you see that? So the net change is going to be minus 2 cos 45 degrees, because we have taken the y direction to be negative here, which means the net change in momentum, as expected, the force is acting in this direction, right? So this net change is negative. So that is expected. So minus 2 into cos 45 is root 2. So that's going to be minus root 2. Or in this case, just the magnitude, right? So magnitude is root 2. And the unit for momentum is going to be kilogram meter per second. Okay. And the direction is going to be downward, and the magnitude is going to be root 2, right? So that is our answer for this, right? So you can see the force actually acts on the ball towards the down, and as expected, the change in momentum is also down, and this time it is 2 cos 45 degrees or under root 2 as a final answer.